Let's take a look at problem 1 from Unit 1, Lesson 4. $3,000 is invested into a savings account that pays 5% interest on January 1st, 2003. The account balance can be modeled by the following equation. We're asked in Part A to graph the model in the appropriate windows. So I'm going to always ask you to begin by clearing your calculator. Let me zoom in so you have a little better view of this. And then we're going to go to y equals, I'm taking 3,000 times 2 raised to, now 0.05x. Okay, so when I look at the windows here, and I'm going to adjust it, and I look at the problem, so let's jump here on your paper, and let's look at part A, B, C, and D. So we're starting at an initial date of January 1st, 2003. I glance at part B, I'm going to go to January 1st, 2010, and part C is going to go to April 1st, 2015. The difference in years from this initial year to what I can see in part B and part C will be at least 12. Now, X is going to represent time in this problem, and Y is going to represent the amount of money in a specific time frame after January 1st, 2003. I want to go to at least past 12. I'm going to try 15. Could you try 13, 14, 20, whatever you need to do, but it should go past 12. As looking at part C, I need to go to at least April 1st, 2015. I know that's past 12. All right, then I'm going to do zoom fit, so zoom 0. And for part A, you will want to draw the picture you have, and it's important that you also label what's the minimum and maximum for both the X and the Y values. So if I go up to window, I could do 0 to 15 for my minimum and maximum X value, and 3,000 to 5,045 for the minimum and maximum Y value. Let's go on to part B. Now in part B, it asks how much was in the account January 1st, 2010. Now this is the key. From January 1st, 2003 to January 1st, 2010 is exactly 7 years. There's no additional days. So X being the time since January 1st, 2003, that's exactly 7 years after. I can go second trace value, typing in 7. And now I'm going to round to the nearest cent. So $3,823.68. Similar to part C, but now there's this additional leftover or partial of a year. So from 2003 to 2015 is a difference of 12 years. But then we have this additional portion. How many days after January 1st is it to April 1st? And it tells us there's 91 days. So it's a part of a year. When I plug it in, I need to account for that partial year. So it's 12 plus, in parentheses, 91 divided by 365. And again, I'm going to round to the nearest cents, so $4,586.61. Now, what's different about part C is now they're asking in what year. So we want to know the X value, and we're told the Y value is 5,000. When you're provided a Y value, you're going to come back to your graphing calculator, and we're going to use the keystrokes we learned earlier in this unit about finding an intersection of two lines. So again, I have our two functions in this case. So I have two different functions. I'm going to graph them. Here's where they intersect. To find that exact intersection, I'm going to go second trace down to intersect, and I'm going to press enter 3 times. Enter, enter, and enter. What does this tell me? It tells me at what point, based on this model, can we approximate when the savings count will have reached 5,000? Now, in the directions here, it wants your answer in terms of years and days. Notice this is not an exact amount, so it's not exactly 14 years. It's a little bit more than that. So I'm going to write down this real quick, 14.739312. Okay. What does this tell me? So I know that there's 14 years, but then there's this partial, 0.739312, and we're going to multiply that times the number of days in a year, which is 365. So we could say after 14 years and 269 days, we can assume the savings count will have reached $5,000.